Very good morning to all of you. Thank you for joining the lecture. Today we are going to start the second module, that is auto transformer. So let us begin with auto transformer. Already we have seen what we mean by transformer. We have seen two winding transformer and its working principle is known to us. So what exactly the auto transformer is, we are going to discuss the same in this lecture. Basically, auto transformer is nothing but it is a transformer. Okay, so how it is different from transformer, let us find out. Auto transformer is a transformer. It will be having only one winding, and this one winding is going to act as a primary and secondary winding. So basically it is a transformer which is having one winding, and this one winding is serving the purpose of primary as well as secondary winding. So if you are having such type of transformer, we will call it as auto transformer. So here is the picture. What you could see, that there is one winding, and this winding is connected with the supply, and the same winding you could see that it is connected with the load. So this only one winding is going to act as a primary as well as secondary winding. You could recall the two winding transformer where there were two different windings. Okay, so one was connected with the supply and the another one was connected with the load. So basically if you think over two winding transformer or simple transformer, so you will find out that the primary and secondary winding, they are not electrically connected. It is isolated. But this is not the case of auto transformer. You could observe there is only one winding. So how you can consider that it is electrically isolated? So it is not electrically isolated in case of auto transformer. So this is the difference. What the first difference we find out, that it has one winding. The second thing, it is it's primary and secondary. In two winding transformer, that is electrically isolated. They are not electrically connected. There is no connection you could see between primary and secondary. Okay, so let us talk about a little bit more about auto transformer. You are having one winding, we are calling it as primary. It will also serve the purpose of secondary. So let us consider this portion from A to B. Suppose there are one number of turns between this point A and C. In this winding, you can say the winding between winding A and C, there is one number of turns. So on secondary side, how many turns will be there? So which winding we are going to consider as a secondary winding? So basically it will be between B and C, and the number of turns we are considering here the N2. The applied voltage, that will be here V1, the supply voltage, that will be V1 here, and it will be supplied between A and C. And so you could observe one thing here, that the B will also come in between. So the supply will be given to A, B and C. So voltage applied here, that is your V1. So once the voltage is connected or the source is connected to the primary winding, or you can say the ABC. So what would happen? An exciting current that starts flowing in this winding, you can say ABC or AC. So the current is going to flow in this winding, that will be called as here I1. So what would be the value of voltage per turn if you are interested to determine between A and C? That will be given by this applied voltage divided by number of turns. Voltage per turn, voltage divided by total number of turns. So it will give you volt per turn or voltage per turn for this winding AC. So what would be the voltage across the winding BC? So it will be given by your V1 by N1 multiplied by N2. Okay, V1 by N1 multiplied by N2. So that will be your voltage across this winding BC. Now many of you might be thinking that the shown diagram, or what we are talking about, that auto transformer, might be it is a potential divider. We all have studied the potential divider, mostly the resistive potential divider. Try to recall the voltage division law or voltage divider, where we were determining the two voltages. So the picture would be somewhat similar to that. So might be you may have some confusion or maybe a query that is it a potential divider? So let us find out whether it is a potential divider. Can we call auto transformer as potential divider or not? Let us find out. So obvious answer, anyone can blindly guess that it is not a potential divider. Let us find out how. Try to think about potential divider. What is the purpose of potential divider? So you will find out in case of transformer, basically transformer can step up the voltage. When you was working over the potential divider, so was it possible ever you did something like this, increasing voltage from one level to another level, stepping up? So it is not possible with the potential divider. Potential divider will be having more losses. When the losses are high, means efficiency, it would be less. When we are going to compare auto transformer with potential divider, the comparison is always possible with the same rating. So at that time we are talking about the auto transformer may be more efficient. In case of potential divider, whatever power is there which is going to flow or transfer, that will be due to only conduction. But in case of auto transformer, later on we will find out that the complete power is not transformed due to transformer action, but part of power that will be transferred from primary to secondary using transformer action, and part of power that will transfer through conduction. So both action will be there. Try to recall the principle of two winding transformer, where the complete power was transferred due to transformer action only. It is not due to conduction. Please remember this point. Okay, so we are comparing, we are trying to identify the circuit shown here. Is it a potential divider? So it will be not a potential divider, because the power which is going to transfer, that will be due to conduction as well as transformer action. Okay, in case of potential divider, only there will be power flow or transfer that will be due to conduction. In case of potential divider, the input current that will be always more than the output current. But this is not the case in case of auto transformer. Okay, the load current that can be more than input current. This is possible when output voltage is less than input voltage. So if now it is clear that the circuit what we are talking about, the auto transformer cannot be called as potential divider, or potential divider cannot be called as auto transformer. So this is a difference. Okay, let us move on further the working of auto transformer. What we said that auto transformer, in auto transformer, part of power is going to transfer using conduction, and part of power that will be transferred due to transformer action. So let us consider again the same circuit we are going to consider. There is one winding, the terminals you could see we have shown here. This is A, here it is B, it is C. So this winding between A and C, that is called as your primary winding, and which are having the number of turns N1. The winding from here B to C, that is called as the secondary winding, and suppose it is having the number of N2. The applied voltage, that will be your V1, and at the output side you are going to get the voltage V2. Okay, and a load is connected once the switch is closed. So what would happen when you are going to close the switch? So at that time, of course, when you have connected the V1, so what would happen? This I1 that will start flowing. Okay, so it is going to induce working MMF. When the switch is closed, so what would happen? The load will be connected, and your I2 that is going to start flowing. Here we are going to assume that the losses are neglected. So at that time we can consider that input power that is equal to output power. We can write mathematically the input power V1 into I1 cos theta 1, V1 applied voltage, I1 is your exciting current, cos theta 1 power factor. V2 I2 cos theta 2, that is on secondary side voltage, load current, and the power factor cos theta 2. We can also neglect internal impedance drops and losses. If it is neglected, so we can say the cos theta 1 equal to cos theta 2, that is the power factor on primary and secondary, that would be equal. So we are in position to conclude or say that the volt ampere on primary that will be equal to volt ampere on secondary. So it is nothing but V1 I1 equal to V2 I2. So from this equation, alternatively what we can write this equal to V2 upon V1 equal to I1 upon I2 equal to N2 upon N1 equal to K. So try to recall, in case of two winding transformer, this is nothing but your transformation ratio. So the same thing you are getting here in case of auto transformer, that is the transformation ratio. V2 upon V1 equal to N2 upon N1 equal to I1 upon I2 equal to some constant K. We are calling it as transformation ratio. Okay, so what could be the value of K? The value of K is less than unity, less than 1. Its value is less than 1, and this K is nothing but similar to the transformation ratio of two winding transformer. So you are getting the same expression. Now let us try to understand more for this figure. So what would happen when you have connected supply? So your I1 that is starts flowing. Okay, what we are trying to understand, what would be the current basically in the winding when we are saying there is only one winding and it is serving the purpose of primary as well as secondary. So what would be the value of current? So when you have connected supply, so at that time what would happen? The exciting current I1 that will start flowing. So it will start for the given polarity, it will start flowing from A, B, C in this direction, in downward direction. So there will be a working MMF, and when your switch S is closed, at that time what would happen? The current that will start flowing from C to B, and a working MMF is going to develop. There is working MMF due to this applied voltage. Once the switch is closed, there will be working MMF. The current here that will be flowing from A, B, C, okay, and from for this secondary circuit, current direction will be from C, B and through load. This will be the direction. It means what you could understand that for this winding B and C, there are two currents. Okay, one is due to primary, the another one is due to secondary. So from here, the I1 is flowing in this direction, and for secondary, the I2 is flowing in this direction. So we can determine the current, the value of current in this winding, that will be given by I2 minus I1. We can write that I2 minus I1. So why we are saying the I2 is considered here greater than I1? Why? Because your V2 that is considered as less than V1. V2 is less than V1, so we are considering that I2 is greater than I1. You know the circuit law, when you have to take the minus sign. Otherwise, what you could do, if your V1 is less than V2, so at that time I1 will be greater than. So I1 minus I2. But in this case, what would happen? Your V2 that is less than V1. So we are considering the current will be I2 minus I1. So what we can write? We can write the MMF in this winding AB from here to here. The MMF of winding AB, what it will be? It will be given by, MMF is nothing but voltage multiplied by the number of turns. So for this winding A to B, the current is I1. What is the number of turns? That you can easily calculate. The total number of turns here is N1, and till here B to C it is N2. So what will be the number of turns? For this A, between A and B, it will be given by N1 minus N2. So the MMF that will be given by I1 into N1 minus N2. Hope the things are clear to you. Alternatively, what you can do, you can also write this I2 minus I1 into N2. Why we can write? Because we know that I1 N1 equal to I2 N2. Okay, I1 N1 equal to I2 N2. Okay, you can write it in that way. So I1 N1 that is equal to I2 N2. So considering this, you can rewrite this expression in this form, I2 minus I1 into N2. So what is the I2 minus I1? It is nothing but the current ICB, which is flowing here from C to B. The current is flowing. So ICB into N2. So basically what it is nothing but MMF of winding CB. So what you find out, what we have seen here, that MMF in winding AB is equal to MMF in winding BC. The same thing we have shown in this particular diagram. So you could understand that the number of turns we have determined A to B, this is N1 minus N2, the current here flowing, that is I1. So how much current is flowing from C to B, that is I2 minus I1. The number of turns here is N2. So basically we have redrawn this diagram here. Okay, so from this what we concluded, that whatever the volt ampere is transferred in this winding, that is equal to the volt ampere transferred in this winding. Okay, so we can write here the transferred volt ampere in AB, that will be equal to, you can write the voltage VAB multiplied by the current flowing in this winding. Suppose that is IAB we are considering. So VAB into IAB. What is the IAB? IAB is nothing but your I1, and what would be your voltage VAB, that will be given by V1 minus V2. Okay, so total input volt ampere transfer to transformer, that will be the applied voltage multiplied by this current. So input volt ampere, that will be V1 into I1, that will be equal to output volt ampere. So from here what we can determine the transformed volt ampere divided by input volt ampere. So transferred volt ampere, that will be given by V1 minus V2 into I1 divided by input volt ampere is nothing but V1 I1. So from here after simplification what you are going to get, it is equal to 1 minus K. So basically what we can conclude here, we can conclude that there is total volt ampere, input volt ampere is V1 into I1. Okay, total input volt ampere is V1 I1. So only this portion, that is V1 minus V2 into I1, that is going to transform to the output, that is on the secondary side, by transformer action. Here what we understood, that total volt ampere out of whatever certain portion of volt ampere, that is only transformed by transformer action. The K is coming here, 1 minus K. Okay, and the rest whatever is remaining from input volt ampere, that is going to transfer through conduction. Okay, so let us find out how much will be conducted through conduction. So conducted volt ampere, that can be written equal to total volt ampere minus whatever is going to transfer through transformer action. So that will be subtracted. You can put that in mathematically. Total volt ampere is V1 I1. We already seen that how much is going to transfer through transformer action. So this amount is there, that will be equal to V2 I1. So from here we can write this conducted volt ampere divided by input volt ampere. So this is equal to K. How much it was transforming through transformer action, it was 1 minus K, and here it is K. We can neglect the internal impedance drop or leakage impedance drop. So we can determine transformed power to input power ratio, that will be given by 1 minus K, and the conducted power divided by input power, that will be given by K. So these are two important expressions which we need to keep it in mind. From this expression also we can write this inductively transferred power divided by total power equal to high voltage minus low voltage divided by high voltage. So I think a few things are clear to you, that in case of auto transformer, some of the power that will be transferred due to transformer action, and some of the volt ampere that will be transferred due to the conduction. Okay, but this is not the case with the two winding transformer. Okay, so please remember this thing in case of auto transformer. So let us move on. Let us try to find out advantages of auto transformer over two winding transformer. So first we are going to consider auto transformer and try to find out, because it contains only one winding, so let us find out, is there any amount of copper saving? Can we save the copper if we are using only one winding instead of two winding? So let us find out that. So transformer can have winding of copper or aluminum. So we are going to consider the weight of conductor for any winding. Basically it depends upon cross sectional area, that is one factor. The another factor is length of conductor, and the area, conductor area, basically that is proportional to the quantum or the current, the amount of current which the winding is carrying, or that conductor is basically carrying. And the length of conductor in winding, that will be proportional to how many number of turns are there in winding. So if suppose 1000 turns are there, so length will be accordingly to that. That is written. So weight of conductor we are going to determine. So weight of conductor for a winding, that will be proportional to the current and number of turns. So for this circuit, we can write the winding AB. Basically, there are two windings we are considering. So winding AB, which is carrying current I1, and it has number of N1 minus N2 turns. So weight of conductor for this winding, that will be given by this AB equal to or proportional to N1 minus N2 into I1. I think there is no doubt. Okay, weight of conductor, that depends upon the factor. So we can write the weight of conductor in this winding AB, that will be proportional to N1 minus N2 into I1. Winding BC, that is carrying basically I2 minus I1 current and having the N2 number of turns. So weight of conductor, that will be given by, it will be proportional to I2 minus I1 into N2. So total weight of conductor in winding AB plus BC, that will be the summation of these two expressions. So that will be basically proportional to these two values. So you can write that here, I1 into N1 minus N2 plus I2 minus I1 into N2. So after simplification, just multiply it inside and then simplify it. So you will find out this 2 into N1 minus N2 into I1. Hope till here you do not have any problem. So total weight of conductor in auto transformer, that will be proportional to 2 into N1 minus N2 into I1. Now we have to compare this thing with two winding transformer. Okay, so here the comparison always done with basically which is having same input and same output, if you are comparing with a two winding transformer. So suppose you are having an ordinary transformer which is having voltage V1, V2 and current I1, I2 in primary and secondary side, and also assume that both are having the flux density, the maximum value of the flux density and core area, that is equal. Okay, already we have seen that what would happen if the flux density is different. So losses will be different, so efficiency will be different. Basically we are going to consider the same transformer here. So the EMF per turn, that will be basically given by this ET is equal to root 2 pi F Bm AI for two types of transformer, that is your two winding transformer as well as considered auto transformer. So the two winding that will have must have N1, the number of turns, that will be given by V1 by ET, means the number of turns in primary and secondary, that will be equal basically. Then only we can make the comparison that how much copper can be saved. So N1 and N2, that will be basically given by this expression. So in case of two winding transformer, what will be the weight of conductor? It's quite simple. I1 is their current in primary, N1 number of turns is there in primary. So I1 N1, that will be number of weight of conductor in primary winding. Similarly, the weight of conductor in secondary winding, that will be I2 N2. Total weight will be the weight of conductor in primary plus weight of conductor in secondary. So that will be mathematically given by this one. It is proportional to I1 N1 plus I2 N2. Alternatively, what we can write? We can write this 2I1 N1. It can be written. So now we are going to find out the ratio. We are having the weight of conductor for auto transformer, that is calculated. Weight of conductor in two winding transformer, that is calculated. So substitute its value. We are going to get this expression 2 into N1 minus N2 into I1 divided by 2 into N1 I1. Okay, so simplifying, after simplifying, what we are going to get? We are going to get this is equal to 1 minus K, or what you can say, the weight of conductor in an auto transformer, that is equal to 1 minus K multiplied by weight of conductor in two winding transformer. So now you can consider any value and you will find out what exactly is happening here. So weight of conductor in auto transformer, that is 1 minus K. K is nothing but transformation ratio. So you are subtracting something, 1 minus K, then you are multiplying with weight of conductor in two winding transformer, so you could understand that how much copper or whatever material, whether it is aluminum, that can be saved. Okay. Alternatively, you can write this expression in this form: the conductor weight in two winding transformer minus conductor weight in auto transformer, that will be K times conductor weight in two winding transformer. So what would be the saving of conductor material? That will be K times conductor weight in two winding transformer. This is an important expression which you need to keep it in your mind. If you are using the auto transformer, it means it will be more economical when the voltage ratio K is near to unity. If voltage ratio, transformation ratio, that is near to unity, so at that time the optimal choice will be of using auto transformer instead of two winding transformer. So this expression usually come into your university examination, so you need to derive that. Hope the things are clear to you. Hope we are not moving too fast. That is one advantage. Okay. The another advantage, what would be that it will be having high efficiency. Why the high efficiency will be? The auto transformer would have high efficiency when we are comparing with the same rating of two winding transformer, because there is a reduction in conductor material. When conductor you are utilizing the less conductor, means losses will be less, I square R losses, that will be less. The second thing, also there is reduction in the core material. Core, the amount of the quantum of material which is required for building core or construction of core, that is also reduced. So core losses will be less. When the losses are less, efficiency will be high. So that will be your another advantage. The third advantage would be in case of auto transformer, you can get superior voltage regulation when you are comparing the two winding transformer. Why? Because the auto transformer will have lower value of leakage impedance when we are comparing with two winding transformer. So basically this is ultimate result of your reduction in conductor material and winding which will be having. Due to that, basically what is happening, your leakage impedance value is lowering. So when there is lower value of leakage impedance, so you are having better or superior voltage regulation. Okay, so these are the advantages of auto transformer. Now we talked about advantages of auto transformer. Is there any disadvantage of auto transformer? Can anyone think about that? Now we know auto transformer, we know two winding transformer. We have seen certain advantages of auto transformer over two winding transformer. Can anybody think, is there any disadvantages? Possible disadvantages? Just try to think, you will find out at least one. Can you use this transformer at all the time in place of two winding transformer? We have seen what we said, when it is preferable, when your voltage transformation ratio is near to unity, at that time it is a better choice. We said that. Okay. So considering this, just try to think what would be the disadvantage of transformer. Anyway, let us see what are the disadvantages. If the ratio of transformation K differs far from unity, the economic advantage of auto transformer over two winding transformer decreases. Already we said that when it is transformation ratio is near to K, at that time it's unity, then it's fine. But when you are moving from unity from 1 to some lower values, at that time it is not preferable. We have seen in case of auto transformer there is one winding. Basically there is no isolation between primary and secondary. So this is a disadvantage, major disadvantage, or you can call it as main disadvantage of auto transformer. So what would happen, there will be high voltage that is directly going to appear in the secondary side, you can say. Okay, basically when primary is supplied at high voltage side on HV side, so what would happen, then an open circuit in the common winding BC, it is going to result in the appearance of very high voltage on the LV side. So this high voltage, you could think, when there is high voltage, so what would happen to the load? Directly the load is subjected to that high voltage when it is connected on LV side. And the moreover, you can say when somebody is working over that, so he will be also subjected to this high voltage. So in such case, some protection, suitable protection is required. So this is a disadvantage because there is no isolation. The other disadvantage would be here the short circuit current in case of auto transformer, that is higher than when we are comparing with the corresponding two winding transformer. So these are basically disadvantages of auto transformer. The major one is the high voltage is going to appear on the LV side when your HV is connected, supply is connected. Okay. One more comparison which is not in your module basically, but let us see. A two winding transformer can be used as an auto transformer when you connect its two winding in series electrically. If suppose you are having a two winding transformer and you want to make it auto transformer, so what you can do, connect both winding in series, so you will get one winding, you got auto transformer. So at that time, let's see what would happen to the rating. So at that time, the rating, kVA rating will be given by this expression. The kVA rating of auto transformer, that will be the ratio, you can say, the kVA rating of an auto transformer to kVA rating as a two winding transformer. The same transformer is converted into auto transformer, so it will be given by 1/1 minus K. All these expressions are required for your competitive examination. In terms of the losses, so the losses, the per unit full load loss as auto transformer divided by per unit full load losses as two winding transformer, that will be equal to 1 minus K times. That will be 1 minus K time. It means the per unit full load losses as auto transformer equal to 1 minus K times the per unit full load losses as two winding transformer. So that would be a lesser effectively when you are making it as a auto transformer. Impedance drop, that will be given by, again that will be equal to 1 minus K per unit impedance drop as an auto transformer divided by the per unit impedance drop as a two winding transformer equal to 1 minus K. Voltage regulation, the regulation of an auto transformer, that will be equal to 1 minus K time regulation as two winding transformer. Short circuit current, that will be equal to the per unit short circuit current as an auto transformer will be equal to 1 by K, 1/1 minus K it is just a reciprocal, you could see here, the per unit short circuit current as an auto transformer to per unit short circuit current as two winding transformer, that is basically inversely proportional to 1 minus K. So these expression it is required for your competitive examination. If we talk about the application of auto transformer, so mostly in single phase and three phase circuit it will be used for interconnecting power system which is having voltage ratios not far away from unity. Already we said that if the transformation ratio is near to unity, at that time we must prefer this transformer, because there is economics is involved. Okay, you can save a certain amount of money, losses will be less, so basically it is going to reflect in saving economics basically. The second thing, for obtaining variable output voltage when used as variable ratio auto transformer, these are known by their trade names, what we are calling it as variac, demonstrate, auto state. So what we are using in our electrical machinery lab, so that is basically your auto transformer, variac, demonstrate and auto state. Let us show you that variac single phase variable ratio auto transformer. See, this is not in your module, but for our information we have just shown here. So what we mean by the variac is nothing but variable ratio auto transformer. The only thing is that it is having a toroidal core. You could see that you have seen physically also in lab, and you could see in this diagram that the core that is toroidal, and in that the winding is wound. So there is only one winding which will be act as your primary as well as secondary winding. So there will be basically a sliding contact. You could see here the sliding contact is there. There is basically the carbon bus is there to make the contact. So the position of this, basically the sliding contact, which is varying by one hand wheel, that already you have seen. So what would happen when you are wearing that sliding contact? So it is going to change your output voltage, that already we have seen when you are moving from 0 position to 220 position. So it is changing basically its voltage. So particularly a variac, which is used for starting induction motor, synchronous motor at reduced voltages, is commonly called as an auto transformer, starter or starting compensator. So this is the diagram for this single phase variac. Just for our information, this is kept it here. Do not confuse with that variac, that is nothing but auto transformer. Because of application we are calling it as a variac, or when it will be used for starting the induction motor, at that time the method name is given that auto transformer is starting. Okay, so this is all about auto transformer. Okay, if there is any question you can ask, otherwise we are going to stop here. Yes, those who are in online mode, they may ask question. Otherwise we will stop here.